We can also go from our mixed radical form and go the other way and convert it into a whole radical. And to do that, what we're going to do is take the outside part and put it inside. So we take that outside factor of 6, and it has to be a factor, and we put it under a square root. And to put under a square root, we're going to square it. We square that going in, we square root coming out. So we're squaring this going into the square root. And once we have it in the square root, we can put those square roots together, and we end up with 36 times 2, and we get the whole radical of 72 going in this direction. So we can go from whole radical to a mixed radical, or mixed radical to whole radical. So in this example, we have square root of 125. It is a square root, so we're going to look for the perfect square, that factor of 125. And the perfect square that divides into 125 is going to be 25. So we end up with 25 times 5. Let's put that under a black square root here. So we end up with 25 times 5, which is equivalent to 125. We're going to split apart the square root 25 with the square root of 5. And again, it's an implied multiplication in there. And then rewrite this as 5. Square root of 25 is 5, and we're left with a square root 5 on the inside. So we're square rooting, taking that factor out, and it ends up being 5. For 208a cubed, we're going to look for perfect square factors in here. And the largest perfect square that's going to divide into 208, so I would take my calculator and I can check that. 208 divided by, it's probably divisible by 2, so 16 I'm going to try. Okay, and that's the largest perfect square that will divide into 208. So I'm going to go 16. We're going to do 16, and then the non-perfect square part of that is going to be 13. So 16 times 13 gives us a 208. We also have to look at the a cubed, and the largest perfect square that we can take factor out of that is a squared. And we're left with a. So the red part represents our perfect square part. We can take that out. 16a squared times the square root of 13a. 16a squared is a perfect square, which is 4a, and what's left behind is 13a. Now I've written a number of steps, and as we get better at this, we can kind of skip some of these steps as we go along. But we've taken the perfect square of 16a squared outside and expressed it as 4a on the outside of that radical. The reverse can be done as well. So we can take that outside term and put it into the root. In this case, we have to be careful because it is a cube root. And so when we put inside a cube root, we have to cube it. So expressing this inside the cube root is going to be 27, or 3 cubed, times 4. And again, if there has to be times there, it's implied times, and it has to be multiplication, because we know that radicals and pluses don't work together. But once we've done that, we can multiply that together. 27 times 4 works out to be 108. So 3 cube root 4 is the same as cube root 108, and we can always check that on a calculator if we're not sure. For ordering radicals, it is much more useful to be able to express these as whole radicals, because as whole radicals, that inside term represents the area of the squares that we're talking about, and the square root represents the side length. And we can then order the side length, the the magnitude of the side length, or the square roots, by just considering how big the original square was. So when I compare these then, I'm going to express 208. Well, that's already as a whole radical. So I'm going to convert 2 root 50 into, I'm going to put the 2 inside the square root to square it. So I'm going to get 4 times 50, which is 200. Okay, so these are equivalent. Same with the 7 root 4. I'm going to put the 7 on the inside, so I'm going to square it. So I get 49 times 4. That gives me 196. So now I express this as a whole radical. These are equivalent. 360 is already a whole radical, so I'm going to go to the next one. The 5 goes on the inside. We square it. So we get 25 times 9. That gives us 225. So we have this expression equal to this expression. Now we can compare all the whole radicals. So the smallest square is going to be 196. So our smallest radical then is going to be 7. It's going to be 7 root 4 is going to be the smallest. The next smallest square is 200. So 2 root 50 then represents the next smallest. The next one is going to be root 208. Okay, then it goes 5 root 9, and then the largest is going to be root 360. So another way we could do this is we could just type these into our calculator, so we can check the decimal values. On the calculator. So when we check the decimal values of these, we do 7 times square root 4. Well, that's actually just going to be 14. We know that that's 14. 2 root 50, well, that works out to be a whole number of 2 times, well, that's not a whole number, so 2 root 50. 2 times square root 50. That decimal value is 14.14. Root 208 gives us a decimal value of 14.42, which is slightly bigger. 5 times square root 9, that's going to be 15. And square root 360. Square root 360 works out to be 18.97. So we can see by the decimal values that we have them in the right order.